On September 27, 2023, at 2:42 p.m. Coordinated Universal Time, NASA astronaut Drew Callahan was 73 minutes into a routine maintenance EVA on the exterior of the International Space Station's Columbus module when his helmet camera registered something that should not exist. The thermal imaging overlay on his heads-up display showed an anomaly on solar panel array 4B, 17 degrees Celsius, warmer than the surrounding aluminum framework. In the vacuum of space, where temperatures swing from minus 150 Celsius in shadow to plus 120 in direct sunlight, localized heat signatures don't just appear. They indicate active systems, electrical shorts, or catastrophic equipment failure. This was none of those things. Drew Callahan, 39 years old, former FA-18 Super Hornet pilot with 2 combat deployments, father to a 7-year-old daughter named Maya, was on his 3rd ISS mission with 412 cumulative days in orbit. He had conducted 22 previous spacewalks. He knew every bolt, panel, and thermal characteristic of this station. What appeared in his camera feed as he maneuvered closer defied every hour of that experience. Adhered to the exterior surface of the solar array, partially obscured by the mounting bracket, was a crystalline structure approximately 47 centimeters in length. It was translucent, refracting sunlight through what appeared to be an internal lattice of branching pathways. The structure was asymmetrical, organic in its irregularity, and as Drew adjusted his position to get a better angle, his helmet camera's spectroscopic analyzer began feeding data to Houston that would trigger an immediate quarantine protocol. The readout showed a composition that included complex proteins, amino acid chains, and cellular structures with defined membranes. Organic matter. Biological material. Exposed to hard vacuum, cosmic radiation, temperature extremes that would shatter steel, and the unfiltered ultraviolet bombardment of unshielded solar wind. No known organism could survive these conditions. Earth-based extremophiles, the toughest bacteria found in deep-sea thermal vents or frozen Antarctic lakes, would be flash-frozen and radiation-sterilized within seconds. Yet the spectroscopic data was unambiguous. This structure contained the chemical signatures of life, preserved in a crystalline matrix that somehow maintained integrity in an environment designed to destroy organic molecules. Houston's response came after the standard 8-second communication delay. The voice was Mission Control's lead flight director, call sign Capcom, and the tone was measured but urgent. ISS, Houston. Confirm visual on anomalous contact, solar array 4B. Initiate sample collection protocol, Echo 7. Do not make direct physical contact until containment verified. Drew had trained for biological contamination scenarios, theoretical exercises involving Martian sample returns, or lunar regolith analysis. He had never expected to use those protocols 408 kilometers above Earth, on a space station that had been continuously occupied for 25 years. He deployed the articulated sample arm from his mobile storage unit, a mechanical extension designed for handling debris or damaged components. The crystalline structure detached with minimal force, suggesting it had adhered recently, not through years of micrometeorite bombardment and thermal cycling that would have fused it permanently to the aluminum. As the sample settled into the reinforced containment cylinder, Drew's heads-up display flashed a new data stream from Houston. A file code he didn't recognize, classification level he'd never seen in routine operations. The header read, Apollo-Soyuz Test Project, July 1975. Film Archive Declassification November 2022. The connection made no sense. Apollo-Soyuz had been the first joint American-Soviet space mission. a symbolic handshake in orbit during the Cold War, designed to test compatible docking systems and ease geopolitical tensions. It had been a success, a footnote in space history textbooks, 17 years before Drew was born. What could a 50-year-old mission possibly have to do with what he'd just collected? Houston's next transmission provided the answer, and it redefined everything Drew thought he understood about what humanity had encountered in low Earth orbit. ISS, the cellular structure you've collected, shows a 73% genetic sequence match with biological material filmed during Apollo-Soyuz terminal phase docking, logged by backup crew member Logan Brenner. The footage was classified under National Security Directive 41. You're holding evidence that we've been looking for since 1975. 6 hours after Drew Callahan sealed the containment cylinder and brought it through the Quest airlock into the pressurized environment of the International Space Station, the sample was transferred to the Microgravity Science Glove Box in the European Space Agency's Columbus Laboratory module. The MSG was a sealed workstation designed for handling hazardous materials in orbit, with redundant HEPA filtration, negative pressure containment, and enough shielding to protect the crew from chemical spills or biological contamination. It had been used to study combustion physics, crystal growth, and fluid dynamics. It had never been used to analyze something that might be alive. Dr. Sierra Kovacs, the ESA mission specialist assigned to the station's biology experiments, was 42 years old. Born in Prague 7 years before the Velvet Revolution, educated at Cambridge, where she'd earned her doctorate studying extremophiles in the sulfuric acid lakes of Ethiopia's Danakil Depression. She had published 63 peer-reviewed papers on organisms that survived in conditions previously thought incompatible with life. Bacteria that thrived in pH levels that would dissolve human tissue. Archaea that reproduced in superheated volcanic vents where water remained liquid only under crushing pressure. Microscopic organisms that could hibernate for millions of years, waiting for conditions to improve. She thought she had seen the boundaries of biological possibility. The sample Drew had collected redefined those boundaries completely. Under the MSG's electron microscope, magnified 8,000 times, the crystalline structure revealed itself as something far more complex than initial scans had suggested. The lattice wasn't just a protective shell. It was an active cellular framework, organized in geometric patterns that resembled both the hexagonal efficiency of honeycomb and the fractal branching of neural networks. Each cell, roughly 3 micrometers in diameter, contained what appeared to be organelles similar to mitochondria, the powerhouses of Earth-based cells. But these organelles were doing something that violated every principle Sierra had learned in 2 decades of studying extremophile biology. They were converting hard vacuum into metabolic energy. The data streaming across her monitor showed that the cells were actively consuming ultraviolet C radiation, the most energetic and destructive wavelength of sunlight, the same radiation that sterilizes surfaces and destroys DNA, and using it as a power source. Not just surviving exposure, but thriving on it. The metabolic rate increased in direct correlation with UVC intensity. When Sierra positioned a calibrated UV lamp near the sample, cellular activity spiked by 47% within 90 seconds. The organism wasn't dormant, it wasn't fossilized, it was feeding. The impossibility deepened when Sierra ran thermal stress tests, protocol for any biological sample that might return to Earth. She cooled a single extracted cell to minus 270 degrees Celsius, 3 degrees above absolute zero, the temperature where molecular motion nearly stops. The cell maintained structural integrity. She heated another cell to plus 180 degrees Celsius, hot enough to boil water under pressure and denature every protein in Earth-based life. That cell also survived. But the truly impossible part, the observation that made Sierra call Drew to the laboratory window and replay the thermal imaging 3 times to confirm she wasn't hallucinating from sleep deprivation, was that the organism could maintain both temperature extremes simultaneously. The outer cellular layers registered -270, while the inner core remained at +180. A thermal gradient of 450 degrees Celsius across a structure 3 micrometers wide. The second law of thermodynamics states that heat flows from hot to cold until equilibrium is reached. This organism apparently hadn't received that memo. Sierra transmitted her preliminary findings to Houston through the encrypted medical channel, the same data pipeline used for crew health telemetry, and requested access to the declassified Apollo-Soyuz footage that Drew's mission briefing had referenced. The response came back within 20 minutes, faster than standard document retrieval, accompanied by a video file marked Eyes Only, ISS Biological Research Team. The timestamp showed it had been uploaded to NASA's secure servers in November 2022, 11 months before Drew's discovery, suggesting someone had anticipated they might need this footage again. The video quality was poor, 16mm film converted to digital, showing the characteristic grain and color shift of 70s-era Ektachrome stock. The perspective was through a small porthole window, looking out at the black void of space and the curve of Earth's atmosphere 7,200 kilometers below. The camera operator's reflection was barely visible in the glass, a young man in his early 30s with dark hair and the focused expression of someone filming something they knew they shouldn't be documenting. The time code burned into the corner read, July 24, 1975, 1300 hours GMT. For the first 40 seconds, nothing happened. Then, entering the frame from the upper left, backlit by the unfiltered sun, came something that moved with fluid, peristaltic motion through the vacuum. It was translucent, approximately 60 centimeters long, and it propelled itself without any visible means of thrust. No expelled gas, no reaction mass, no electromagnetic interaction with Earth's magnetic field. It simply undulated, contracting and expanding in rhythmic waves, crossing the field of view in 11 seconds before disappearing beyond the edge of the porthole. The footage continued for another 31 seconds, the camera operator holding position, waiting to see if it would return. It didn't. The video ended abruptly, a physical cut in the film suggesting someone had edited the footage before archiving it. Sierra played the movement sequence in slow motion, then overlaid it with her microscopic footage of the cellular sample's growth pattern. The peristaltic rhythm matched. Not approximately, not close enough to suggest similar biology. Perfectly synchronized. One complete contraction-expansion cycle every 2.3 seconds in both the 1975 footage and the 2023 sample. The probability of that being coincidence was statistically negligible. These weren't just the same species. Based on the identical metabolic signature, the matching cellular structure, and the synchronized movement pattern, they could be the same individual organism, separated by 48 years and 700 kilometers of altitude difference. Drew floated next to Sierra at the MSG workstation, his expression unreadable in the way that astronauts learn to mask shock during emergency situations. His voice, when he spoke, was quiet enough that the station's ambient microphone system barely registered it. The camera operator in that footage, Logan Brenner, he's still alive, 86 years old, living in Taos, New Mexico. I looked him up in the NASA alumni database while you were running the thermal tests. He was backup crew for Apollo-Soyuz, never officially flew, career ended 6 months after this footage was taken. Violation of filming protocols, they said. But they classified the footage under the same directive they use for nuclear satellite reconnaissance. Sierra didn't look up from her monitor, where she was now running genetic sequencing on the sample's RNA equivalent structures. "Did you contact him?" Drew shook his head. Houston specifically said not to. External communication restrictions during biological quarantine. But I have his email address. And a satellite phone number that routes through a civilian network, not NASA infrastructure. Sierra's hands paused over the keyboard. The ethical boundary was clear. The scientific necessity was equally clear. Sometimes you learn more from the person who saw something 48 years ago than you do from the thing itself. Drew pulled out his personal tablet, the one NASA allowed for off-duty family communication, and composed a message to an email address that hadn't been used in public correspondence since 1997. The subject line was simple: ISS Sample Collection, September 2023. The body of the email was shorter. "Mr. Brenner, we found one. It's inside the station. We need to know what happened after you stopped filming." He hit send before he could reconsider, the message routing through a commercial satellite constellation that NASA's network monitoring wouldn't flag until the daily audit cycle. The response came back in 43 minutes. Not an email. A phone call to Drew's personal satellite line, a number that only his daughter and his ex-wife were supposed to have. The voice on the other end was weathered by age but steady, carrying the same controlled tone that astronauts use when something has gone catastrophically wrong, but panic would make it worse. Logan Brenner had been waiting 48 years for this conversation. His first words confirmed it. "You brought it inside, didn't you? I told them in 75. They don't die. They just wait." Drew put the call on speaker, low volume, with Sierra leaning close enough to hear. Logan Brenner's breathing was audible in the pauses between words, the slight rasp of someone who'd lived at high altitude for decades, and when he continued, his tone carried the weight of someone who'd been rehearsing this conversation in his head for nearly half a century. In July of 75, during the docking sequence with the Soyuz, we observed 3 of them attached to the exterior of the Apollo command module. They weren't there during pre-flight inspection at Kennedy. They appeared sometime during translunar injection, or maybe during coast phase. We brought one inside the docking module for documentation. Alexei Leonov, the Soviet commander, he wanted to study it. Thought it might be some kind of space-borne bacteria, maybe from a comet tail we'd passed through. Within 18 hours, the 3 outside had become 7. Perfect geometric distribution around the hatch seal, like they were trying to get to the one we'd taken inside. Sierra interrupted, her voice clinically precise despite the implications of what she was hearing. Did the interior sample show growth response to human proximity? Logan's laugh was bitter. Decades of suppressed trauma compressed into a single exhalation. Growth response. That's a gentle way to put it, Doctor. It tripled in size over 36 hours. Started emitting heat signatures that matched our body temperature when we got close. The biosensor package we had, primitive compared to what you've got now, registered electrical activity. Neural-like patterns. We didn't have the equipment to analyze it properly, but Leonov was convinced it was attempting communication. Then Houston ordered immediate disposal. Incineration protocol. The module it was contained in had to be jettisoned and deorbited over the Pacific. The official record says equipment malfunction. The actual record is buried under classification I can't even name. Drew glanced at Sierra, whose expression had shifted from scientific curiosity to something approaching dread. She was already pulling up new diagnostic protocols on her tablet, recalibrating the MSG's sensor array for long-term behavioral monitoring. Logan continued without prompting, as if the 48 years of enforced silence had built up pressure that now required release. You asked what happened after I stopped filming. What happened was, they disappeared. All 7 of them, gone within minutes of us jettisoning the interior sample. No trace on radar, no visual confirmation, just vanished like they'd never been there. And I've spent 48 years wondering if they left because we destroyed one of them, or if they left because they accomplished whatever they came to do. Ejun. The call ended there, Logan's voice cutting off mid-breath, as if he'd used up his quota of words and couldn't spare another syllable. Drew and Sierra sat in the humming silence of the Columbus module, surrounded by the station's constant background noise of air circulation fans and cooling pumps, and contemplated the implications of what they'd just heard. If Logan's account was accurate, and if the organism Drew had collected followed the same behavioral pattern, then they had perhaps 96 hours before something changed. But changed into what? And with what consequences for 6 crew members in a pressurized environment 408 kilometers above the nearest hospital? Neither of them wanted to speculate aloud. 72 hours after initial collection, Sierra's behavioral monitoring data confirmed that speculation was no longer necessary. The sample had increased in volume by 340%, filling nearly half the available space in the MSG containment chamber. The growth wasn't random. It was radial, expanding outward in perfectly symmetric concentric rings, each ring precisely 8 millimeters wider than the previous, creating a pattern that resembled tree rings but formed in hours instead of years. The metabolic rate had accelerated exponentially. The organism was no longer just consuming ultraviolet C radiation. It was now processing cosmic background radiation, the faint microwave echo of the Big Bang itself, converting photons that had traveled for 13.8 billion years into biological energy. But the behavioral shift that made Sierra immediately contact Houston wasn't the growth or the metabolic acceleration. It was the response to human presence. When Sierra approached the MSG to collect a tissue sample for RNA sequencing, the organism oriented toward her. Not gradually, not through random cellular drift, but deliberately. The entire structure rotating 30 degrees within the containment chamber to face the point where her hands entered the sealed gloves. Thermal sensors registered a spike in infrared emission from the organism's surface, and the pattern of that emission was not random. Sierra ran the data through the station's signal analysis software, the same program used to decode telemetry from satellites and deep space probes, and the results appeared on her screen with a clarity that made her hands freeze on the keyboard. The organism was emitting pulses at 1,420 megahertz, converted into thermal radiation instead of radio waves. 1,420 megahertz is the emission frequency of neutral hydrogen, the most abundant element in the universe, and the frequency that every radio telescope on Earth monitors when searching for extraterrestrial intelligence. It's called the cosmic water hole, the universal channel where any spacefaring civilization would logically broadcast, because hydrogen is everywhere, and its frequency is mathematically fundamental. The organism wasn't just responding to Sierra's presence. It was trying to communicate using the one frequency that any scientifically literate species would recognize as intentional. Blake Torres, the mission's payload integration engineer and the crew member responsible for monitoring all external sensors and telemetry systems, found Sierra and Drew in the Columbus module 2 hours later with data that elevated the situation from scientifically extraordinary to potentially catastrophic. Blake was 34 years old, had worked at NASA's Jet Propulsion Laboratory for 9 years before transferring to ISS operations, and had a reputation for catching anomalies in data streams that everyone else missed. What he'd caught this time had been deliberately deleted from the official telemetry logs, scrubbed by an automated filter that someone at Mission Control had apparently activated without informing the crew. During Drew's initial sample collection, the station's external cameras had recorded the entire EVA from multiple angles, standard procedure for safety documentation and post-mission analysis. Blake had reviewed that footage as part of his routine systems check and noticed something in Camera 12's feed: the wide-angle lens mounted on the starboard truss that covered Solar Array 4B and the adjacent radiator panels. In the background of Drew's sample collection, partially obscured by the station's structural elements but visible in 17 frames of high-resolution imagery, were 23 additional structures identical to the one Drew had collected. They were distributed across the exterior hull in a pattern that wasn't random. When Blake plotted their positions on a three-dimensional model of the station, the geometry resolved into a perfect hexagon, with each structure positioned at mathematically precise intervals, centered on the Columbus module where Sierra now housed the collected sample. And all 23 of them, according to the timestamp metadata embedded in the camera feeds, had begun synchronized growth within 6 minutes of the interior sample being transferred into the MSG. Blake showed them the thermal overlay, false color imagery, that mapped surface temperatures across the station's hull, and the pattern was unmistakable. 23 hot spots, each one growing warmer and larger in perfect synchronization, arranged in hexagonal geometry around the module that contained their sibling. The implications were immediate and deeply disturbing. The organisms weren't isolated individuals. They were networked, coordinated, operating as a distributed system with the interior sample as either a beacon or a focal point. That night, at 0300 hours GMT, while the crew was supposed to be on sleep cycle, Drew's personal tablet chimed with an incoming email notification. The sender was Logan Brenner, the subject line blank, and the message body was a single block of text that read like a deathbed confession from someone who'd carried the weight of classified knowledge for too long. In 1975, there were 3. When we brought one inside the Soyuz for study, the other 2 multiplied. They were 7 when we managed to eject them. The one that stayed inside had to be burned. The entire docking module. That part doesn't exist in any official record. You've had yours for how long now? 72 hours? You have maybe 96 before they become too many. And when I say burned, I mean we heated the module to 1600 degrees Celsius and held it there for 40 minutes. Even then, we weren't sure we got all of it. Some of the cellular fragments were still showing electrical activity when we jettisoned the debris. Drew forwarded the email to Sierra and Blake, then initiated a priority communication request with Houston. The response from Mission Control was immediate, the voice of the lead flight director calm, but carrying an undertone of scripted precision that suggested the words had been carefully prepared in advance. ISS, Houston. We copy your communication request. Biological containment protocols are being reviewed by the science team. Maintain current isolation procedures. Do not attempt any disposal actions until we transmit updated guidelines. Acknowledge. Drew acknowledged, then waited for further instruction. The communication channel went silent. Not the normal silence of waiting for the next transmission, but the specific quality of silence that comes from an actively severed connection. 47 minutes passed with no contact from Houston, no response to repeated hails, no explanation for the communications blackout. 47 minutes. The exact duration of radio silence during the classified incident in 2023 that involved Russian cosmonaut Elena Petrova, an incident whose details were still buried under classifications that exceeded Drew's security clearance. When Houston finally re-established contact, the voice on the other end was different. Higher authority, unfamiliar call sign, tone that carried the weight of decisions that had already been made. ISS, this is Flight Director Actual. New mission parameters are being uploaded to your secure terminal. Commander Callahan and Dr. Kovac, you are to isolate in Columbus module effective immediately. Remaining crew will transfer to Russian segment. This is a mandatory quarantine directive under Biological Containment Protocol Kepler 7. Acknowledge and comply. 89 hours after Drew Callahan collected the sample from Solar Array 4B, Houston transmitted a mission directive that reconfigured the entire operational structure of the International Space Station. Drew and Sierra were formally isolated in the Columbus module, with the connecting hatches to the rest of the station sealed and locked from the external controls. The remaining 4 crew members, 2 Americans, 1 Russian, and 1 Japanese astronaut, transferred to the Russian segment and were instructed to maintain minimum communication with the quarantine section. The official explanation, transmitted on open channels that ground stations worldwide could monitor, cited biological containment protocols for unknown organic material pending classification review. The unofficial explanation, delivered through encrypted point-to-point communication that bypassed normal mission control routing, was far more specific and infinitely more disturbing. The sample hadn't come from space. Orbital trajectory analysis, conducted by NASA's Jet Propulsion Laboratory using radar tracking data and thermal imaging from the Defense Department's Satellite Reconnaissance Network, showed that the crystalline structure had formed on the exterior of the ISS during a specific orbital pass over the Pacific Ocean. The timestamp correlated exactly with the station's transit across the Mariana Trench, the deepest point in Earth's oceans, where the seafloor drops to 10,916 meters below sea level. Atmospheric physicists at JPL had run fluid dynamics simulations and determined that under specific conditions involving upper atmospheric turbulence and the station's orbital velocity of 17,150 miles per hour, it was theoretically possible for material from the ocean surface to be lofted into the thermosphere and collide with low-orbit spacecraft. But the Mariana Trench isn't the ocean surface. It's 11 kilometers down, buried under pressure that exceeds 1,000 atmospheres, in darkness so complete that the concept of vision becomes meaningless. The implication was impossible to reconcile with any known biological mechanism. The organism hadn't drifted down from space. It had risen up from Earth's deepest abyss, somehow surviving passage through 11 kilometers of water, then 90 kilometers of atmosphere, then 317 kilometers of vacuum, to crystallize on the hull of a spacecraft traveling at 5.4 kilometers per second. The energetics alone violated basic physics. The biological resilience required exceeded anything in the evolutionary record. Yet the orbital tracking data was unambiguous, confirmed by 3 independent analyses, and NASA had no choice but to accept what the evidence demonstrated, even if the mechanism remained inexplicable. Blake Torres, working from the Russian segment with limited access to NASA's classified databases, managed to locate a historical precedent that had been buried in the National Oceanic and Atmospheric Administration's archives for 63 years. In January of 1960, the bathyscaphe Trieste, piloted by United States Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Piccard, descended to the bottom of Challenger Deep, the lowest surveyed point in the Mariana Trench. The dive set a record that stood for 52 years. The official mission report documented the descent, the 20 minutes spent at maximum depth observing a flatfish and shrimp that proved complex life could survive even there, and the successful ascent. What the official report didn't document what had been classified under naval intelligence protocols and only declassified in 2018 as part of a routine archival review, was the 16mm film footage taken during the final ascent phase. The footage, grainy and underexposed due to the limitations of underwater photography and near-total darkness, showed the exterior of the Trieste's pressure sphere as it rose through the water column. At timestamp 43 minutes 12 seconds, as the bathyscaphe passed through the Hadal zone approximately 8,000 meters below the surface, translucent structures became visible adhered to the hull. They were smaller than the sample Drew had collected, perhaps 15 to 20 centimeters in length, but the morphology was unmistakable. Crystalline lattice, asymmetric branching, the same refractive quality that made them appear to glow with their own internal light. The footage captured 11 seconds of clear imagery before the structures detached and sank back into the abyss. Navy biologists in 1960 had classified them as unknown cnidarians, possibly a deep-sea jellyfish species exhibiting unusual attachment behavior. No follow-up research was ever conducted. The footage was filed and forgotten. Sierra ran a comparative analysis between the Trieste footage and her microscopic imagery of the ISS sample. The cellular structure matched. The branching pattern matched. Even the way light refracted through the internal lattice matched, despite the 63-year gap and the radical difference in environmental pressure. These weren't different species adapted to different extremes. They were the same organism, capable of surviving at both ends of the pressure spectrum that should define the absolute limits of biological possibility. 11 kilometers underwater at 1,000 atmospheres, or 400 kilometers above Earth in hard vacuum. Extremes where water boils and freezes simultaneously, where proteins denature and DNA shatters, where the very chemistry of life as science understands it becomes impossible. Yet this organism thrived in both environments, suggesting an evolutionary origin so ancient and so alien to conventional biology that it predated every extinction event, every continental shift, every environmental catastrophe that had reshaped life on Earth. Logan Brenner's final communication came not as an email, but as a video call, unauthorized and unencrypted, routing through civilian satellite networks that NASA's security protocols couldn't monitor, without revealing that they were actively surveilling a private citizen. His face appeared on Drew's tablet screen, 86 years old, but still carrying the bone structure and focused intensity of the astronaut he'd been half a century ago. He didn't wait for pleasantries or confirmations. He simply began speaking, as if he'd been waiting for permission to unburden himself, and now that permission had finally arrived. "I didn't contact you to explain what they are, Commander Callahan. I contacted you to explain what they want. In 1975, when the sample we collected started emitting those thermal pulses, we had a radio astronomer on the ground team, consultant from Arecibo Observatory. He recognized the frequency immediately. 1,420 megahertz. The hydrogen line? Universal communication channel? We didn't have the equipment to decode the message, but we recorded it. 3 months after Apollo-Soyuz, the recording was analyzed by NSA cryptographers. The message was simple. 4 words in binary code. Waiting for conditions suitable. Logan paused, his expression carrying the weight of 48 years spent knowing something that he'd been legally prohibited from sharing. It didn't specify what conditions, but I know what they are, Dr. Kovacs. You know too, if you've run the cellular analysis. They're not invaders. They're not aliens. They're spores. Dormancy capsules from something that existed on Earth before anything we'd recognize as life. They're waiting for the planet to become uninhabitable again. Waiting for the oceans to boil or freeze. waiting for the atmosphere to strip away, waiting for us to disappear. Sierra's voice was steady when she responded, but Drew could see her hands trembling as she gripped the edge of the workstation. We've run radiometric dating on the sample's crystalline matrix. The formation is 3.8 billion years old. That's the age of Earth's oldest rocks. This organism predates the oxygenation of the atmosphere. It predates photosynthesis. It might predate cellular life as we define it. DT, the philosophical implications settled over the Columbus module like a physical weight. Humanity had spent centuries searching for evidence of life beyond Earth, scanning the cosmos for radio signals, analyzing Martian soil for bacterial fossils, hypothesizing about subsurface oceans on Europa and Enceladus. And all along, older than anything in the fossil record, patient beyond human comprehension of time, something had been waiting in the places humans never looked because they seemed too extreme to harbor life. Not alien, terrestrial. Earth's original inhabitants, dormant in the abyss and the void, waiting for conditions to reset. 117 hours after Drew Callahan collected the crystalline structure from Solar Array 4B, NASA authorized the execution of Protocol Kepler-7, a contingency plan developed in the early 2000s for handling biological contamination scenarios in low Earth orbit. The protocol's name referenced Johannes Kepler, the astronomer who first calculated planetary orbits, because the solution involved orbital mechanics rather than conventional sterilization. The sample, still contained within the microgravity science glove box, was transferred to a reinforced disposal module, sealed with triple redundant containment, and loaded into the station's trash airlock. At 0900 hours UTC on October 2, 2023, the module was ejected on a trajectory calculated to intersect the Sun's photosphere in 47 days. Not into solar orbit, but directly into the star itself, where temperatures exceeding 5,000 degrees Celsius would reduce any known form of matter to constituent atoms. The 23 structures adhered to the exterior hull were removed during a series of carefully coordinated EVAs, catalogued with precise documentation of their positions and cellular characteristics, then similarly ejected on solar trajectories. Each disposal was recorded, each containment procedure verified by multiple independent observers, each trajectory confirmed by tracking stations on 3 continents. The International Space Station then underwent what NASA officially termed comprehensive thermal maintenance, a 72-hour process where every pressurized module was heated to 160 degrees Celsius, well above the temperature required to denature proteins and destroy cellular structures. The crew evacuated to 2 Soyuz spacecraft during the procedure, waiting in orbital holding patterns while the station's interior became hot enough to sterilize surgical equipment. When they returned, air quality monitors confirmed 0 biological contamination above background levels. Drew Callahan and Sierra Kovac were returned to Earth 34 days ahead of their scheduled mission completion, landing in Kazakhstan on October 19th aboard a Soyuz descent module in conditions described as nominal by Russian mission control. What the official reports didn't mention was the 90-day quarantine period both astronauts underwent at NASA's Johnson Space Center in Houston, a duration that exceeded any previous biological isolation protocol by 53 days. During that time, they were subjected to medical examinations that went far beyond standard post-flight physicals. Cellular analysis, genetic sequencing, neurological imaging, psychological evaluation. The results were never published in NASA's medical journals. Both astronauts signed non-disclosure agreements that carried classification levels typically reserved for signals intelligence and weapons systems development. In March of 2024, 8 months after the incident, NASA published a carefully worded paper in the journal Astrobiology titled Unidentified Extremophile Organisms in Low Earth Orbit, Preliminary Analysis and Containment Protocols. The abstract mentioned complex organic structures of undetermined origin and successful quarantine procedures, but provided no specifics about cellular composition, behavioral patterns, or the historical context connecting the discovery to the Apollo-Soyuz mission 48 years earlier. The paper was cited 17 times in subsequent research publications, primarily in the context of planetary protection protocols for future Mars sample return missions. None of the citations mentioned the Mariana Trench, the Trieste bathyscaphe, or the possibility that the organisms were terrestrial in origin. Logan Brenner, 87 years old, gave a single interview to an independent aerospace journalist in April of 2024. The interview was published on a website that specialized in declassified space program history and received minimal mainstream attention. His statement was brief and carefully phrased to avoid violating the security oaths he'd signed in 1975. "We discovered something that had been here longer than we have. Something that survived every extinction event, every environmental catastrophe, every change in atmospheric composition that wiped out 99% of species that ever existed. And it's still here, still waiting." Teet. When pressed for details about what it was waiting for, Logan simply smiled and ended the interview. Sierra Kovacs resigned from the European Space Agency in June of 2024 and founded a private research organization called the Deep Extremes Initiative, funded by a consortium of universities and technology companies interested in astrobiology and extreme environment engineering. The organization's stated mission was to study life in Earth's most hostile environments, with particular focus on high-pressure ecosystems in oceanic trenches and low-pressure survival mechanisms in the upper atmosphere. Her first expedition, launched in September of 2024, deployed autonomous submersibles to map the Hadal zone of the Mariana Trench, using imaging technology far more sophisticated than what the Trieste had carried in 1960. Drew Callahan did not return to space. His official NASA biography lists him as transitioned to ground operations, consultant for biological contamination protocols, and planetary protection systems. He works from an office in Building 30 at Johnson Space Center, reviewing proposed missions for biological contamination risks, with security clearance that allows him access to classified data from every space agency on Earth. The persistent mystery, the 20% that remains unresolved, emerged in January of 2025 when Sierra's Deep Extremes Initiative published preliminary findings from the Mariana Trench expedition. The autonomous submersibles, operating at depths exceeding 10,000 meters, had mapped a field of crystalline structures covering approximately 1.2 square kilometers of the seafloor in the Challenger Deep region. The structures were arranged in hexagonal patterns, identical in geometry to the distribution observed on the ISS hull. Thermal sensors detected infrared pulses emanating from the structures at regular intervals. The frequency of those pulses, when converted from thermal radiation to electromagnetic equivalent, measured 1,420 megahertz. The hydrogen line, the universal channel, still broadcasting after 3.8 billion years. But the detail that Sierra included in the paper's supplementary data, buried in an appendix that most readers would skip, was the one that kept Drew awake during the nights when he couldn't stop thinking about what they'd brought inside the station, and what might still be waiting in the abyss. The crystalline structures in the Mariana Trench weren't dormant. Chemical analysis of water samples collected near the formations showed elevated concentrations of dissolved carbon dioxide, far higher than ambient oceanic levels. The structures were actively absorbing CO2 from seawater, processing it through an unknown metabolic pathway, and storing it within their cellular matrices. They had been doing this for an indeterminate period, possibly centuries, possibly millennia. And according to geochemical modeling conducted by Sierra's team, the absorption rate had increased by 47% over the past 200 years, correlating almost perfectly with the rise in atmospheric carbon dioxide from industrial activity. The structures had a biological clock, triggered not by time but by environmental conditions, specifically atmospheric CO2 concentration. Historical ice core data showed that during previous mass extinction events, the Permian-Triassic extinction that killed 96% of marine species, the Cretaceous-Paleogene impact that ended the dinosaurs, atmospheric carbon dioxide had spiked above 450 parts per million before the extinctions reached their peak. Current atmospheric CO2, as of January 2025, measured 426 parts per million, rising at approximately 2.5 parts per million per year. Simple mathematics suggested that if current trends continued, Earth's atmosphere would cross the 450 threshold in approximately 9.6 years. Drew Callahan, in a private conversation with Sierra that was never officially recorded, but that both of them remember with perfect clarity, articulated the implication that neither of them wanted to acknowledge publicly. They're not waiting for random conditions. They're waiting for a specific threshold. The same threshold that preceded every major extinction in Earth's history. And we're 24 parts per million away from triggering whatever comes next. Sierra's response was quieter, but carried the weight of someone who'd spent 8 months analyzing the most ancient form of life on Earth, and recognized something in its patience that approached inevitability. They've survived for 3.8 billion years by waiting for everyone else to die. And they're very, very good at waiting. The question that hangs unanswered, the mystery that defines the 20% still unresolved, isn't whether humanity discovered alien life or terrestrial life or something in between. It's whether the organisms in the Mariana Trench and the ones that crystallized on the hull of the International Space Station are simply surviving in extreme environments, or whether they're preparing for something. Whether the message they've been broadcasting on the hydrogen line for uncounted millennia is a greeting or a countdown. And whether crossing that 450 parts per million threshold will simply be another data point in climate science, or the activation signal for something that has patiently waited through the rise and fall of every dominant species Earth has ever produced, waiting for its turn to inherit a planet that humans, in their brief geological moment, mistakenly thought belonged to them.